All right, so in class today we started talking about inequalities. If you were absent or didn't get the chance to write the beginning of this down, make sure you title the next page in your notes with the words Intro to Inequalities. These are the sections that we're going to be covering in the next couple of weeks, and your test is scheduled to be next Friday, so it's a really quick little unit, and this lesson is just to kind of get us re-familiarized with inequalities. So, looking here, we talked about, which would you prefer to have, 4 or 6? Why $6? Well, because 6 is greater than 4, or in other words, 4 is less than 6. Okay, is 3 less than or greater than 1? Well, we know 3 is bigger than 1, or it's greater than 1. Okay, you don't have to write this down, but I'd like you to write what I'm going to write on the side over here. So we talked about other words for less than and greater than. Okay, so some words that came up for less than was like smaller than or fewer than. Greater than, we had more than as another choice, or bigger than. Okay, so make sure you jot these down. These are words that could come up in word problems, and we need to know how to translate it into the symbols for less than and greater than. All right, so all you really need is these two things right here, okay, with the different words. So that's what needs to be written down. All right. As far as symbols go, okay, for less than, it looks like this. Okay, think about, we read from left to right, right? So as you read this sign, you go from small to big. Okay, so whatever's over here is smaller than what's over here. Okay, so it goes from small to big. For greater than, it goes the opposite way. As we read the sign, we hit the big side first, so it goes from big to small. Okay, again, reading the sign, we hit the big side first, and then the smaller side. So it goes from big to small. This is greater than this side. Okay, so make sure you have these symbols written down. And I would write the words below as well, the small to big and big to small. Okay, maybe these examples you want to throw in there. We read this as 4 is less than 5. We read this one as 8 is greater than 5. Okay, so maybe you want to put this as an example for greater than and this as a quick little example for less than. Okay, they're both true statements. Obviously, 4 is less than 5 and 8 is greater than 5. Okay, so make sure you have the symbols and a quick little example in your notes. All right, so now let's try to bring in some negatives, focusing on the left side here. What's the correct symbol? So if I have -3 and a +4, well, this is a negative, so if I think about a number line, this is 0. -3 would be like over here somewhere, and then +4 is way over here. So the -3 is going to be less than 4, right? That's definitely, if I have -$3, I definitely have less than if I had $4. So the sign goes this way. This is the smaller end. This is the bigger end. Okay, so -3 is less than 4. In fact, I can really say any negative number is going to be smaller than a positive number. Okay, you can think just about the number line. No matter where you are on the negative side, you're always going to be further to the left than if you're somewhere on the positive side. All right, so this question, it says, which would you prefer to owe, $3 or $2? You don't have to write that down, but it kind of goes with thinking about negatives. So if I owe $3, that's kind of worse, right, than owing just $2. So I would rather owe 2 because I have more money, right? If I only owe $2, in some way I have more money, right? We can also think of a number line here. If this is 0, -1, -2, -3. Okay, -3 is further over to the left, so this one is going to be smaller than -2. Okay. -3 and -4, well, -4 is even further over here, so that one is smaller. So -3 is bigger, so I would say -3 is greater than -4. -9 is more negative, or I can think it's further that way, right? It's further to the left, so it's the smaller number. It's less than -7. Okay, what's interesting here, or maybe something that could be an easier way to help you remember this, is that it's going to be the opposite of if we had positives. So if I had 9 and 7 as positive numbers, 9 is going to be bigger than 7, right? If I had $9, that's more than having $7. But if I owe $9, then I have less money than if I only owed $7. Okay, so there's kind of an opposite quality here when we have both of them negatives. All right, here's just a little trick. Remember, we can't say 5 is less than 5 or 5 is greater than 5. It's just that 5 equals 5. Okay, so maybe you want to write down a couple of these. Okay, maybe this little note about how they're opposites. Okay, maybe you just kind of use your own judgment. Think about how many examples you need to help you, what's going to be helpful to look back at. All right, so here we played a little game in class, right? Looking at if these were true or false. 2 is less than 3, so that's true. 4, this sign is less than or equal to. So this says is for less than 5 or equal to 5. Either one of those is okay. It's less than 5, so that is true. Okay. -1 bigger than 4 is not going to happen. That's going to be false because a negative is not going to be bigger than a positive. Okay, 1 bigger than -4 is true. Positive is bigger than a negative. -2 greater than -1 is not true, right? The -2 is more negative, so this is a smaller value. Okay, so that is false. It should be less than. 3 is greater than 4 is false. Just going to kind of run through these quickly. -1 less than or equal to is true. -1 greater would not be true. Decimals, don't freak out, right? Again, just think of that number line. This is a number between 1 and 2. So yes, it is less than 4. This is a negative, so I don't even care that it's a decimal. I know that a negative is not going to be bigger than a positive, so that's false. Okay, looking at the fractions, maybe you want to think about like pie charts here. 1/2 and 3/4. 1/2 is smaller than 3/4, so the smaller number is 1/2. The bigger number is 3/4, so that looks good. That's true. 1/2 bigger than 1/4 is also true. Here I've got a negative less than a positive, so that's true. Positive greater than a negative, true. Okay, so even when I have fractions, some of them should be fairly automatic. Okay, if you're looking at like positives and negatives, you should be able to tell. All right, so maybe copy down just like these fraction ones. Okay, so you can have those to refer to. And moving on to the next slide. What symbol goes between these? Again, just kind of some practice. -6 greater than. Look at that interesting little switchy quality, right? There's something opposite about it, right? 6 is less than 10, but -6 is bigger than -10, right? Because -10 is way down here. -6, 0. It's almost like a reflection. Interesting. Okay, so 5 and -4, that's bigger. That one's smaller than that. -6 is more negative, so that's a smaller value, so it's less than -4. If you want to put that on our number line, it'd be about here. Okay, so negative 6 is the smaller number. It's less than negative 4. 1/2 is bigger than 1/4. But again, keeping with our mentality of this opposite thing, negative 1/2 must be smaller than negative 1/4. I can look at a number line here again. If this is 0, this is negative 1. The middle would be negative 1/2. And negative 1/4 would be in here. Okay, so the negative 1/2 is farther this way. It's farther to the left, so it's smaller. Okay, so that's going to be less than. And then, of course, for the positive case, on the flip side, we would have 1/4 here and then 1/2 here. So the 1/2 is bigger when it's positive. A little review with percentages here. 20% is the same as 0.2, which is greater than 0.02, right? This is like 2/100ths, and this would be 2/10ths. Okay, so this is a smaller amount, okay? Or if I wanted to switch it to a percent, it would be 2%. So 20% is bigger than 2%. Whew, okay. Moving along. On this page, you really don't need to copy these. Maybe just pick a couple or some of these opposite ones, like the fractions and the first couple would be good. All right, so don't write this, just let's do this. Write the words inclusive inequalities. Okay. This symbol. Okay. This less than or equal to symbol. Okay, represents less than or equal to. And then this symbol represents greater than or equal to. Okay, we call them inclusive inequalities because they include the equal case. Okay. Can you think of other words or phrases that might be used to describe? Okay, so let's make another little table like we did for less than and greater than. So if we have, let's just do the symbol, less than or equal to. Some other ways that we could say that, and then greater than or equal to. These words are a little tricky because sometimes it's not what you would think right away. Let's think if I was like buying lunch and I could spend at most $10. Okay, I would want the amount that I could spend is at most $10. So the amount I could spend would be less than or equal to $10. So less than or equal to, another way of saying that, less than or equal to, would be at most. Okay, or I could say no more than. I can spend no more than $10. Okay, the other way around would be like, well, just the opposite. So at least or not less than. So this would be like saying I can spend at most $10. Okay, for the greater than or equal to, put that there. For this one, maybe I would say like I want to earn at least $10. All right, so I kind of wrote in what that would look like. If I wanted to earn at least $20 at a job, for instance, or like $20 an hour, it would look like this because I want the amount that I earn, I would want to be greater than or equal to $20, okay? So that would be examples of that. Okay, so everything that I have underlined on the left and then the markings on the right should be written down. Okay, moving on. This is not how it's supposed to look. Okay, sorry, we'll look at that later. For right now, how many solutions does the equation x equals 7 have? Well, this would just have one solution. Okay, it's just when x is 7, right? 7 equals 7. That's the only number that x could be. With inequalities, we have more solutions. If we look at like x greater than 7, this right here says x in n, that means x is a natural number or like a counting number. So it's like 1, 2, 3, etc. So if x is bigger than 7 and a natural number, well, it could be 8, could be 9, could be 10, could be 11. It could really be anything bigger than that, right? So there would be infinitely many solutions there. Okay, this is kind of like a word problem. So Emily has at least, remember at least is going to be greater than or equal to. So Emily has at least $200 in her savings account. So maybe like S is her savings account money. So S is at least, okay, is greater than or equal to 200. This, remember, says at least. Okay, so go ahead and ignore this. We're not going to worry about that. Ignore that, and if you could write these, that would be helpful. So go ahead and write these on the left. How many solutions? X equals 7. How many solutions to this? Remember, this is just what that means. And then the first part of this, Emily has at least $200 in her savings account, goes to that equation. Okay. Okay, and there's more problems that I wanted to cover, but let's just look at these three. You don't have to write all of them, okay? Just kind of, let's summarize. So, speed limit on a certain road is 60 kilometers. Does this mean each driver has to drive at this speed or less? Sure. Some people drive faster, but technically they have to drive at most 60 miles or 60 kilometers, okay? So if S is the speed, how could we represent that? Well, at most 60, so maybe make a note, at most. And if you look back in your notes, we said at most goes with less than or equal to. So their speed should be less than or equal to 60. Okay, so just go ahead, write just this little underline, couple phrases, and then what that would look like in math terms. Okay, B, another example. In order to be able to go on a school trip, Kelly needs to have saved $40 or more. So maybe we could say she needs to save at least $40 or more. Then it says Kelly has saved D dollars and is not yet able to go on the trip. So which of the following is true? Oh, so she can't go. If she can't go, that means she has less than 40, right? Because she needs $40 or more, so that means she has less than 40. Okay, so maybe I could write she needs, if X is like how much money she needs more than or equal to $40. She can't go, so she must have less. Okay, last example here. Before we're done, it says to enter a particular art competition, you must be at least 12 years old. Tom is N years old, and he can enter the competition. Which of the following is true? He can enter. So, at least 12, he is at least 12. So, N is at least 12, which means he's older than or exactly 12. So, we would say that. Okay, so we'll go ahead and stop there. You know, it seems like a lot. Again, these word problems, just a quick summary is what I'm looking for. So like just really what I have underlined or maybe a little bit more if it helps to make more sense. Okay, there is plenty more practice problems. If you would like to kind of practice this, make sure you're getting it. I'll kind of flip through them right now. You can pause if you want to practice those. Okay, so here's a few more. And some more examples. Oh, that's another thing we won't talk about. We'll talk about that later. Okay, so make sure again that you have written down what is supposed to be written there, and we will talk about some solving inequalities tomorrow.